Okay, guys, quickly. 4 topics, and they just follow each other like that in your paper. Electrostatics, circuit, electromagnetism, and photoelectric effect. But multiple choice for you quickly there. Please, guys, for the 1 minute, 45 seconds. Here, let's try. 1 minute, 40 seconds. Quickly. All right, can we share answers quickly? Populate on the chat box quickly. Let's make it interactive. Yes, okay. Nzalo? Nzalo is raising her hand. Sandra says C. Yusera says C. Shamil C. Mohammed C. Okay. Nzalo, your hand is up.
No, it's an answer.
Sorry?
An answer.
Yeah, what's your answer?
So I haven't started this question.
You haven't started?
Yeah, I just questions.
Okay, great. Unfortunately, we won't be able to wait for you. So flow with us in terms of what the possible answer would be. 2 positive charges Q and positive 4Q are placed at a point X and X and a point Y, respectively, as shown in the diagram below. A positive small charge Q is kept at rest. That's a keyword there. It's kept at rest between point X and Y. So F net equals to 0. Okay. It means the force on the left-hand side. So the force pulling the object to the right is equal to the one pulling it on the left. Remember, it is held stationary now. When Q is released, Q will... Oh, lovely. Please. It is held there. It is held there at stationary point, so it will still remain at rest. All right, because all the forces around it remain what? At equilibrium. So the object is not moving. Huh? Zero calculation. Nah. Okay, guys, quickly. Any other thing there? We're good. Next one. Next one. Let's put some time here. Uh, 12 marks. Let's put 15 minutes. I hope you have your formula pages with you, please. I give you 40 seconds extra from my kind heart. Hi. Yes. Yes, Sarah?
So what's the 83.91?
It is the F-net, the direction of the F-net measured from the negative x-axis.
So it's the direction of the net.
Yes.
Okay. Thank you.
All right. Okay, guys, do we have right answers for this? Because I know we do have answers. The question is, are they right? Are they right or are they right? Okay, let's look at what the examiner is all about here. All right, first question, are you able to answer that? Were you able? For the first time you did your definition?
Oh, no. Free body.
And you were able to draw a free body diagram? Okay, 1 second. Okay, let's look at this question and see what the examiner is all about here. Let's see what they are all about. Okay, a small metal sphere A with charge of negative 60 Newton and a mass of 0.02 is suspended by an inextensible light string with negligible mass. Another two small positively charged spheres B and C held on insulating stands with charges starting that are brought closer. Okay, the net electrostatic force acting on B due to the presence of A is of A and C is that, and that's the direction. State Coulomb's law, guys. Please, I don't want to embarrass you, so I'm going to skip. Number 2, please let's go learn Coulomb's law. I know we should know that the magnitude of the electrostatic force acting on any two objects is directly proportional to what? The product of the charges, and inversely proportional to the square of the distance between them. Please note their centers. Distance between them. Okay. Free body diagram. What can you tell me? On A.
Tension.
Alright, it's been held by a rope there, so we have tension. What else? There's gravity. You know, we're told it has a mass. But what do you notice? A is negative and B is positive. So B is actually pulling A. Can we then put that as what? Electrostatic what? Force. You can do that just to create a bit of clarity.
But then C is also positive.
But not on A. C is acting on B. Alright. So this is what? Electrostatic force. And that gives you 3 marks there. Number 3, calculate the magnitude of the tension in the string. I think the object right now should be stationary. A is stationary. So the first thing I know, since A is stationary, F net equals to what? MA. But that F net is what? 0. The question is, what is F net? If we keep this as positive, this as negative, what will it be? Tension plus negative, let's call it electrostatic force, plus minus what? Force of gravity. Okay, I think we know mg. The question is, what is the electrostatic force? No. F net, okay, let's check something here. What we have right now is the F net, and even if we want to use that, we do not work with inclined forces. We always work with vertical forces. So what do we need to do? We need to resolve this into components. And if I resolve this, look at what the vertical would be. All right. I wanted to see the dynamics that's going to happen here. This is FE vertical, while this is what? FE horizontal. Make sense? But because B is stationary, this FE vertical that we are drawing upward is the same as the one going down. What do you think FEY would be? Let's do that separately. What is our electrostatic force, vertical component? I told you that the side facing the angle, we just use sine. Do we know our electrostatic force? 2,72 times 10 to the power negative 4 sine of the angle 83,9. 91 degrees. In fact, why are we doing it separately? So we can bring it in. So what would it be? T minus 2,72 times 10 to the power negative 4 sine 83, what? 91 degrees. Are we together? Minus mg. What's the mass again? 0,02. And what is g? 9,8. That should be equal to what? 0. Please get me the value of tension. 0, comma? Okay, can we confirm? We just put it in the calculator. Can we confirm? And let's quickly talk about that. Do you agree with that? Is that a rounded off value?
Yeah.
Okay. What was the original one? 1957. All right. 195. So 2 decimal places will give us what? 0,2. Let me know if it makes sense, everybody. Let's talk about this quickly. Questions? Let's talk about this. Questions? Yes, Nzalo?
So, is it possible for them to give us a scenario where D is not stationary?
In this case, it will be at equilibrium.
Is it possible though, like, is it like at our level?
What they would give you is they can ask you to calculate the acceleration of an electron.
Okay.
And all you need to do is to say F net equals to what? MA. And we know that we know the mass of an electron from photoelectric effect, 9,11 times 10 to the power negative what? 31. Which will then give us the acceleration of the electron. Are we good? Lovely question. Okay, guys, 7.3.2. What do you think would be the magnitude of the charge on C? Let's look at C quickly. I want us to look at C. What can we say? C is now, once we say C, I think we are moving A away from the whole equation now. So we are dealing with the horizontal. What's happening? They are both positive. So they are repelling. Oh, beautiful. So number what? 7.3.2. F equals to what? K Q B Q C over what? R squared. The question is what is F? It's the horizontal one now. What would that be? 2,72 times 10 to the power negative 4 cos of what? 83,91. What is K? 9 times 10 to the power of what? 9. What else? What is QB? 20 times 10 to the power of what? Negative 9. Multiplied by what? QC. What is the distance between them? But all what? Squared. Please take note, it must always be in meters. What's your answer here? You said what? 5? Negative? Ooh. Can we do it again? That 31 looks weird.
So I'm going 4 times 10 to the negative 8.
4 times 10 to the negative 8. Okay, can we confirm? Any other person with an answer?
So can we not substitute it into the total? So if we say if we really form a right angle triangle between the electrostatic forces.
You want to form a right angle triangle.
So when we say the electrostatic force between AB squared plus BC squared is equal to the 2.72 times 10 to the negative 4 squared.
Wait, what do you want to calculate? What's the aim of your Pythagoras?
To substitute into normal Pythagoras, so then we still have QC as the unknown.
But if you are substituting You don't substitute the Q. Remember, if you are using Pythagoras, you're dealing with the F. I don't know if I'm getting your point and you are getting my point. If I'm using Pythagoras, then I'll say F resultant squared equals to. And that one would only be possible if the examiner asked me to calculate that, which is what they have done already.
Oh, so now we're working that way.
Yes. So now I have this, because I've converted this to that, and I have that. And we know that this force exerted on this force would be the same, and that is the electrostatic force there.
Oh, okay, that makes sense.
Yeah.
Thank you.
Okay, do we agree with the answer?
Yeah,
4 times 10 to the power? I need more participation. I'm only talking to about 3-4 people. I need more participation, please. I know we're exhausted, we're tired. Trust me, you are not as tired as I am. You have no idea. I don't even know how I'm surviving. But we have to keep working. Huh? I was still sending solutions at I think the last one I said was at 140 something. My eyes was closing when I was doing it. I'm like, no, guy, I'm sleeping now.
So I think it's 4.01 times 10 to the minus 8.
01?
4.01 times 10 to the minus 8.
All right. Now, guys, please look at this. If the examiner did not use this word, this answer would be wrong. Never write your charge without a sign. But because they use this word, then I can neglect the plus. So please take note, never write without a sign. Okay, last question. In which direction would the net electrostatic force on B be? On force B be experienced if C was removed? The net electrostatic force. Okay, if we remove B, where should the net electrostatic force be? Sorry, we're removing C. So we have 2 things, right? Let's analyze quickly. We have that, and we have that. This is A, right? And this is what? B. This is negative 60 nanocoulombs. This is positive 20 nanocoulombs. In which direction will the net force be? Mohammed says up. Huh? Upwards. Okay, can I add? Make it 13. Give a reason why. Give a reason why. You're done. The magnitude of the 60. So the number of electrons in A is more than in B. So A would have a greater, not really a greater force. Can I say a greater force? I'm trying to. Because the force they exert would be on each other. So I'm being careful about the word I use there. However, A would have a stronger pull. All right, A would have a stronger what? Pull. It is the reaction of B that makes the force equal. Remember, if object A exerts a force on object B will then what? Simultaneously exert a force. Okay, so this should actually go where? Up. Because we have more here. Or let's say stronger charges, stronger quantity of charges. Guys, are we okay with this electrostatics that we did so far? Let me know. Let's take questions quickly. Let's take questions quickly. You still have a bone to pick here. So, no matter the question you are doing, don't work with what? inclined forces, vertical and horizontal forces. Okay, since there's no question, let's go and work for ESCOM now. Oh, no. We still have this. Still on electrostatic. Okay, let's do this one in 7 minutes. Ooh, 13 marks. But it's possible. It is possible. 10 minutes. Come quickly. First one is definition. Second one is drawing. 10 minutes is too much. Check. First one, definition. Second one, draw. The only calculation is 8.3. It's not a space. It will be a space if it's electric field. Use the formula here, quickly. Once you see electric field at a point, E equals to what? F over Q. Once you see at a point, it is the force experienced per unit positive what? Charge. Okay, I'm cutting time because I've done that. But let's try. Please, let's try quickly. Everybody has a chance to get it right. Okay, guys, let's see what this question is all about. Two small sphere charges R and S are placed 120 millimeters apart. That's a problem for me. Divide by what? 1,000. Please always remember we divide by what? 1,000. Okay, in the vacuum as shown in the diagram below, sphere S has that. Sphere has 7,5 times 10 to the power 12 electrons in excess, and R has a charge of that. All right. You know what they can ask you is S going to be positive or negative? It will be negative. Why? It has excess electrons. Okay. Okay, we defined 8.1. Draw a diagram that shows the net electric field pattern around the two what? Spheres. That shows the net. So we're talking about the combined. Oh, you see what I just did here? It will help us now. So we're talking about a positive and what? A negative. So what do we do quickly? We draw a positive one, we draw a negative one, and what do we know? It's going to be what? An attraction. And it's always moving from where? Positive to. Guys, don't draw too many so that you don't start creating problems. Make sure it touches. And we are done. Let's label it R and S. Case closed. We are done with that. Next question. The charge on sphere S. Okay, what do we know? How do we get charge? Q equals to what? N. Q what? E. Where N is the number of electrons. 7,5. 7,5 times 10 to the power what? And now, what's the charge on an electron? Okay, I like to do that. And that will confirm my answer as a negative. What's your answer? 1,2 times 10 to the power? Coulombs. Now, in this case, you see they said charge. If you don't put the negative, it's wrong. Because the examiner did not say magnitude. So it's important. I hope we're on the same page. All right, you let me know if there's any question on this. And the last one, what are we looking for? Net electric field at point P. Please never do this without drawing a free body diagram. Please. So it's positive, positive, and negative. Please never do this without a free body diagram. Positive, positive, and negative. And we are drawing at P, right? R and what? S. Put your dots there. What's going to happen due to R? It will push that to the right. All right. What are we looking for again? Net electric what? Field. Which is what? E. So can we call this ER? Now what will happen with S? Same direction again, because negative will attract positive. Can we call that ES? Let's take right as positive. So what do we know? E net will be equal to what? ER plus what? ES. What is E, by the way? K QR over what? R squared plus K QS over what? R squared. Can we just throw in the formula values? 9 times 10 to the power what? 9. What is QR, by the way? You don't need the signs. 1,2 times 10 to the power?
Oh no, sorry, I need that 0,7 times 10 to the minus 6.
0,7 times 10 to the power what? Now, but what is the distance? Let's go back to the diagram. Distance, we are focusing on R, right? Distance between R and P. Remember, divide by what? 1,000. 1, 2, 3, 4. What would that give you? 0,004. Please don't forget centimeters by 100 plus 9.
0,04.
Is it 04? Oh, it's 40. All right.
Yeah.
What is QS?
1,2.
1,2 times 10 to the power what? Over. Now we look at the distance between P and S. What should that be? That's 80. I hope everybody agrees with us. That is what? 80 what? Millimeters. 1, 2, 3. 0, comma what? 0.8. Please give me your answer. We're done here.
5 minutes.
Give me in standard form, please.
5.
Shift mode. Shift mode 7.3. 5, comma 6 times 10 to the power 6. And what's your unit? Newtons per coulomb. Because we are looking at the formula. E equals to what? F over what? Q. Newtons. Do we agree with this answer? Agreement with this answer? Any question? Quickly, let's move.
So in the paper, if you write that 5 minutes.
It's fine. It's fine. I'm just lazy. I don't want to think about 5 million. That content is. We're good. Okay. Let's go forward now. Circuits. Okay. We'll come back to the multiple choice. We'll finish with multiple choice. Ooh. What's going on here? Not bad.
Are we looking at the same circuit?
It depends on the eyes that you're using. He doesn't have shades on, so you can see it clearly.
This one is in CBC. X. This is the X.
There we go, guys. I'll give you 15 minutes. That will take us to 5:30. We're doing good. Then we have 2 more questions. Those 2 are very fast. Please think carefully. Trace current. It looks kind of hectic. Hi guys, we should be done. It's like I gave you forever. We should be done. Even if I walk to the mall, I'll be back. Are we done, guys? Is there anyone who's still busy? If you are not done, please give me a thumbs down. Let's see quickly. Responses, quick responses would help. All right, no one is giving me a thumbs down, so let's work. In the circuit diagram below, the battery has an internal resistance of 0.5 ohms and an EMF of each cell. Very important. That's why they wrote it in capital. Each cell. How many cells do we have? 3. So the EMF is what? 4.5. Lovely. So if you use 1.5, you are cooked already. So please, EMF is what? 4.5 volt. That's why they said each. Both switch S1 and S2 are open. So, do you know I can have both switches open and current still flowing? If both are not main switches. Yes, I could draw a circuit for you and put auxiliary switches inside the circuit, but it won't stop current from flowing.
So what is auxiliary switch?
Okay, or maybe secondary switches. So if you look at this, if you look at this, it's a main switch because it's on the main flow. So if I close this, I can deceive you by opening one. You see, like this one is opened. It doesn't stop circuit from flowing, current from flowing. Current is still flowing. So always watch the main one first. Okay. State Ohm's law. Please, let's get those laws. As long as temperature remains constant. Just use the formula. What's the formula? V equals to what? So the voltage is directly proportional to current. Now you bring in your statement. Yes, because temperature is resistance. Because if I start rubbing my hand against each other, because of the friction, there's resistance, and that generates heat. That heat is the temperature. So the voltage across a conductor is directly proportional to what? The current at constant what? Temperature. With both switches S1 and S2 open, what is the reading on V? It's the EMF, right? So what's our answer? 4.5 volts. What about V1? V1 is measuring what on the switch. Now it is opened. What is the current along that path? 0. So V1 should be what? 0. What about V3? There is still no current because voltage is simply what? I multiplied by what? R. At that point, is there any current flowing? No. 0 volts. Both switches S1 and S2 are now closed, and the equivalent resistance of the resistors connected in parallel is equal to 1. Okay, so they are closed. So R1 and R2 are now 1. Oh, and the reading. Now, please, guys, let me do something here. This is what I like to do when I have to deal with my circuit. I like to write on it. Write what I know on each. Write what I know on each of them. Okay, what do we know? They said they are now closed, right? Let's close it. Okay, let's act as if it's all closed originally. Okay, switches are now closed. Well, very closed. Well closed. Well closed. Okay. What information do we then have? Let's see the information that we have. What information do we have? Reading on A, 1.8. Okay, I'm going to write it first. We don't know whether it's the total. We'll look at it later. What else do we know? Total R parallel, right? Okay. R parallel equals to what? 1 ohms. Lovely. We have EMF. What's the internal resistance? 0.5. And this is what? 4.5 what? Volts. First question. All right, before I look at the first question, what's happening? Current is moving from the positive end. So current moves this way, this way, this way. Wait, just want to clarify something. Okay, hold on. Okay, I'll come back to it. I want to just clarify something there on those 0 I gave. Something's just making a spark on my head right now. Huh? Wait, guys. Wait. I think I'm making a serious mistake. You see, when it's closed, there's current, right? But the switch is of what? Good. So R here is what? 0. It means the V here would be what? Please, can we go back and change this? Let us go back and change this. And we can construct to quickly confirm. This should actually be 4.5. Please, let's quickly note what I did now. I stopped them to rethink. I think I gave you a wrong answer here. All right, but I'll sort this out before we go. I don't want us to get confused. But you understand what I did here, right? Okay. Current flows. What is the current? 1.8. I'll come here and write my 1.8 there. Current continues. Oh, when current gets here, what happens? It splits. And the beauty of this is, look at R and 2R. We can quickly get the current. Let's quickly get the current. What is the value? Look, this is 1 ratio what? 2. So let's divide 1 ratio 2 into, let's divide 1.8 into 1 ratio 2. We still remember grade 8. We add 1 plus 2 would give us what? 3. So we say 1 over 3 times what? 1.8. What's your answer? 0.68. Then 2 over 3. What's your answer? The question is, which one would have 1.2 and which one would have 0.6? The one with the lower resistance will have the higher current. Which one has the lower resistance? R1. So R1 would have what? 1.2A, and R2 would have what? 0.6A. Please take note. Let me know if what I just did made sense to you in terms of ratio. Quickly. I'm waiting for your responses. I need everyone to respond. Are we together? Okay. Now, what are we looking for? The question says calculate the voltage on V2. What do you know? Do you think we can get the voltage on V2?
No, which one says voltage on V2?
No? Or what is the question? Yeah. Calculate the reading on V2. Do you think it's 3 marks? It shouldn't be difficult. What do we do? But do you know R? But why so long? It is. For 3 marks.
Can you say 1 times the 1.8?
Sorry?
Can you say 1 times the 1.8?
No, because the current. Hold on.
I'm getting the potential difference for the whole parallel branch.
Okay.
I'm using the total resistance and the total current
Oh, it's no, sorry.
of the parallel branch.
No, it cannot be 1.8. Let me quickly explain why it cannot be 1.8. It cannot be 1.8. Let's quickly explore. All right. The parallel. Look, V2 will have the same value as V3.
Yeah.
Why? They are connected in parallel. All right, check this. If I combine those, look at what I will have. This is X, and this is my R parallel. These are connected in what? These are connected in. Oh yeah, no, you are. Oh, it's 1 comma. Sorry. It's 1,8. Why? The current here is what? 1,8, and the total R here is what? 1 ohms. You're fine, correct. So we don't need to find R. That's what I'm saying. You know, when you said R, it's just too long. So the total resistance here is what? 1, and the total current here is 1,8, which gives me what? 1,8 volts. But because they are connected in parallel, current is divided, but potential difference remains what? The same. So parallel are current what? Dividers.
You also, to get the formula, I dot del is equal to V parallel over R parallel. And it's so easy. Yeah. It's easy.
Okay. All right. Let's write it down. What's the answer? V equals to what? I multiplied by what? R. What's our I? 1,8, and R is what? 1. So what's the answer? It's 1 mark, 1 mark, 1 mark. Hence I was having a bit of issue when I said we should get R. It's too many steps there.
And the next question requires to
Next one. Calculate the resistance of what? R2. Where is R2? Okay, look at it. They are connected in what? Parallel. How do you get two resistors in parallel? Okay, I don't know if I should do that. Two parallel resistors. What do we know? R parallel is simply what? Product over what? Sum. Do we know R parallel? 1. What do we have? R1 times R2 over what? R1 plus R2. Okay, let me do this. Can we substitute now?
No, so just putting.
Okay, can we substitute now? 1. What is R1? I think R1 is R. And what is R2? 2R. Over what? R plus 2R. Look at how simple this thing can be. 2R squared over what? 3R. That's 3. R therefore is what? Are we together there? Huh? That one was good. But somebody else who doesn't know that, let's work with this. 1 over R parallel, 1 over R1 plus. Now I know my R parallel as 1, right? Then 1 over R plus 1 over what? 2R. So 1 we do product. No, DDD, right? 1 times 2R, 2R plus R over what? 2R squared. Cross multiply. 2R squared equals to what? 3R. What is R? Baby steps. Question, please. Somebody.
Is 1.5, but aren't they asking for the other resistor?
What are they asking for? They're asking for R2, right? Okay.
So is it R2 double R1?
Yeah. So now we know R2 as what? 2R, which is what? 2 times what? 3 over 2, which will give us what? 3 ohms. So whichever method you do, this last step is common. Are we on the same page, guys? Same page? Are we on the same page? Very, very important. Same page. Switch S2 is now open while switch S1 is closed. What effect will this change have on the power dissipated in resistor X? Okay, let's first look at what is the impact of closing what?
S1.
S1 is open?
Oh,
No.
S2 is open.
S2 is open. Okay, so if S2 is open, guys, what you need to do is to understand the impact of that. Let's quickly draw this. Let's do this. Okay, let's open S2 now. Let's leave S2 opened. Let's leave S2 opened. Okay. Which one is open again? S2 is open, right?
Yeah. S2 is open.
S2 is opened. Okay. What happens? This 1,8 will no longer be there. The first thing I'm going to check when all of this happens is what happens to my total resistance. It will? Okay. Are you sure? All right. Total resistance does what? Increases. What happens therefore? The total current will what? Decrease. Because R, it was 1,8. It now decreases. What's the question saying? All right. So it said, what will happen to the power dissipated in X? Before now, the current was what? 1,8. Now we can use the formula P equals to what? I squared what? R. The resistance of X is not changing. So if I decreases, what will happen to P? It will decrease.
But now it's in series. Also.
Okay, wait, let's go back. We start from resistance. What happens to total resistance?
Yeah,
It increases.
Therefore,
What's the relationship?
inversely proportional. So
Total current will then decrease.
Yeah.
It was 1,8 before. Let's say it now drops to 1. So, for me to answer this, this is the way you please answer it like this. For the same resistance, an increase in power or in current increases what? Power. Write that formula that we just used. P equals to what? I squared what? R.
also it will increase.
No, it will decrease. Oh, I wrote increase, right?
So, doesn't your loss volts decrease because your current is decreasing? So your external voltage increases.
No, remember, we're looking at, okay, I'll use voltage to answer that as well. But for now, do we agree with total I would decrease?
But you see, it was first in parallel. Now it's in series. When you put it into series, doesn't I total increase?
No. First, what happens to resistance?
Okay, then that makes sense. It's
So,
not going
always start from
resistance.
resistance. So, the total resistance will what? Increase.
Yes.
Total current will decrease. So from 1,8 it becomes what? Lower. For the same resistance, a decrease in current, I was supposed to write decrease. A decrease in current would decrease what? Power. I'm going to try to use voltage. So power in X will decrease. Yes.
Can I use P is equal to P squared R?
Let's just use that. What happens? We're still going to start with that statement. Okay. Total what? R increases. What happens? Total what? I will what? Decrease. Check now. Lost volt. Because lost volt is IR. It will what? Decrease. Is that fine? But watch now. V external will what? Increase. However, V external is shared. These things are now connected in what? In series. Series are potential what? Although the total voltage increases,
Now share.
it's now still shared. So it will eventually what? Decrease. So V external is shared, hence decreases. Why is it shared? Because they are connected in what? Series. So P equals to what? V squared over R. For the same R, P is inversely P is directly proportional to what? V. Therefore, P will what? Decrease. Don't forget the shared part. Although the total increases, and why again? Check something here. When it was connected when this was still connected, it was still shared though. However, this was taking a smaller portion. But now when it's open, this now takes a bigger portion. Like, hey, when you can't cheat me here. All right? It now takes a bigger portion than it was taken before. Did that make sense? Sarah, you were asking about the V.
So it is because the series circuit is safer to use the current. So
Yes.
you don't mess up the last part.
Yes, because you are likely to forget this part. In fact, you don't know. Yes.
Parallel circuit should we use the voltage?
If it's a parallel circuit, what is remain constant? V. So V will be better to use V there. Because we don't even know how much is taken away. But we know.
Even though the V external increases, it's shared. That's why it decreases ultimately.
Yes, however, I don't do, you see, right now I'm just using the knowledge of science. Yes, it decreases, but I'm really not sure of how much is shared. Except we
So
can.
you can't be certain the exact value of it.
Yes, so that's why I prefer to use what's constant.
Oh, that makes sense.
So if this is constant, 1,8, now it decreases to 1. What happens to the, you see, it's not shared. Power remains, power will decrease. Okay. Power will decrease. Let me know if it makes sense to everybody. I want to know if it makes sense to everybody. Let's answer a multiple choice quickly on this one. And then we do electrodynamics.
So in this same sort of question, the V1, is it 0 volt?
No, I'm going to go back to it now. I'm going to go back to it now. Just give me this multiple choice quickly. I'm going to make that one very clear. Quickly, 2 minutes should be fine. 2 minutes is too much, but it's okay. Give you 10 seconds. let's share answers here quickly, please. With so many in class, but only a few people are participating. Guys, please, even if your answer is wrong, participate. Please. What's the answer here? Aha, people are now waking up. Mohammed, thank you, Zolunga. You share what you know, Nazifa. Beautiful. Consider the circuit below. 3 series. Battery has an EMF of XV. Okay, what is the voltmeter reading across the 2R? Okay, these things are connected in what? Series, right? What do we know? Current is the same. Huh?
Yeah.
Current is the same.
Voltage was split.
Voltage will split. Okay, so we are looking for V. Okay, this is looking interesting. See. Okay, let's look at it. So current remains the same, right? So we have I, we have I, we have I. But what are we given? We're given the voltage. All right. Let's do a bit of maths. What's the total resistance? 4. Okay, so what is my current? V equals to what? IR. What is your V? X. What is your I? We don't know. But what is the voltage? What is the resistance? 4R. So what is my I? X over what? 4R. Can I then come here and calculate the voltage here? What is the voltage? V equals to what? IR. Current is the same, right? So what would it be? X over what? 4R. What is my resistance? 2R. Twi. What's your answer? X over 2. You use values. Okay, fine. Did it make sense? So these questions, they always want you to just quickly pick. Don't. Very tricky. Okay, before we move away from circuit, I want to fix this thing here so we have a proper understanding. 4.1 is correct. 9.1 is correct. 9.2.2. Guys, there's no current flowing. But that voltage there on the switch will still measure what? EMF. But when the switch is closed, it will measure 0. Please take note. When the switch is closed, the potential difference there will be what? 0. Closed switch. V equals to 0. Why is V 0? There's no resistance, so it's not doing any work.
If they tell you that conducting wire is a resistance or something, you add it to
Yeah, if
external.
yeah. Okay, what about V3? Please watch. There's a value of a resistor on V3. Right? There's a resistor R2 there. The question is, there is no current flowing. Is there any work being done? No. That becomes what? That's the one that is 0 volts. Let me know if it makes sense. The difference between the 3. I'm actually glad this question is coming up. Talk to me. I need us to clear this. Please ask. You understand why V1 is what? The EMF, right? Still measuring across. But when the S1 is now closed, V1 becomes what? 0. This explanation. With V3, yes, there is a resistance there, but I is equal to what? 0. So V is 0 multiplied by the value of the resistance, and that is 0 volts. Beautiful. So take note of that. That's a very lovely one, and I'm glad. Yes.
It is going to if you want to register voltage specific current.
Mohammed, can you be more articulate with what you're saying? because I'm really struggling to pull up the words.
I'm saying for V1, so to read the voltage, there needs to be current flowing through the part that it's open.
V1 will, V1, no, okay, I get what you're saying. You see where, let's go back. With the way it is, that's a switch, right? Where is it again? With the way it is right now, it is a switch. Because it is a switch, this V is actually measuring the entire energy of this. The difference between this and this, there's no resistance here. There's resistance here. So take note of that. There is no resistance here. There is resistance. And that will be 0. Here there is no resistance. So this voltage is measuring exactly what this is measuring. Because it is measuring the potential energy across the circuit. So please take note. I can show you if we have some time. We do a little construction there just to make sure that your mind is settled. Huh?
So this road people like kind of like closes the circuit.
Yes, I can hear you very well.
So there's V1 kind of like closes the circuit. So it's complete.
V1 is what?
Does it like complete the circuit?
No. A voltmeter doesn't complete a circuit. A voltmeter doesn't complete a circuit. The voltmeter measures the amount of work that will be done across the circuit. So V1 is measuring the amount of work done here because there's no resistance there. Okay, so please just quickly take note. No resistance on the switch. This would measure EMF. Closed, if I close it, it becomes what? 0. So please don't let's just quickly learn that and so that we're not confused. All right. Quickly, let's answer this multiple choice. This one, guys, 30 seconds. Very straightforward. 1 minute here, no time here because we need to answer. A learner lists the following as factors that affect the magnitude of the current induced in an AC generator. The strength of the magnetic field, the speed of rotation, the number of turns. Will all of these affect the magnitude of the current? The strength of the magnet, yes, it will affect. The stronger the magnet, the stronger the magnetic flux. The speed of rotation, yes, if you increase the speed of rotation, what happens? We increase current. Number 3, number of turns. If it increases, answer is what? D. No argument. Are we okay, guys? Please get back to your notes. We did all of this in proper details. Okay, come quickly. Let's answer. We have only 30 minutes left. Some are doing accounting. These questions usually take about 5 minutes. Come quickly. You have 7 minutes. 7. Not more than 7. Huh? I don't know. Open your eyes. You didn't even read. You're already looking for slip rings and split rings. Read first, papi. Okay, quickly, guys, let's answer. I want to answer all of this in 3 minutes or so that we have our photoelectric effect done. The diagram below shows the simplified diagram of an electric machine. Study the diagram below and answer the questions that follow. When the coil is in the indicated position, the current inside the coil flows from P to Q. Okay, let's put an arrow there, like that. What type of electric machine? What's your answer? And give a reason. Is this a motor or a generator? Talk to me. Motor or generator? It's a generator. All right. Why?
Because it doesn't have a cell.
There's no power source, right? No power source. We don't see any battery there. No power source. Name the principle under which this machine operates. Stop lying. Electromagnetic induction.
Yeah.
In fact, we should say Faraday's law of electromagnetic what? Induction. And the motor would work on the principle called the Motor effect. Name the function of component D. What's D? Name and function of component labeled D. That's basically an external circuit. It could be anything.
Yeah.
All right? It's an external, but in this case we can see that it's actually measuring. So this one we can call it a voltmeter. All right? Voltmeter measuring the direction of flow of current. But that question really, we could argue a lot of things there. We could really, yes?
Can you say it's like a thermometer?
A galvanometer would look like this. Here, this one, we could actually argue a whole lot of things. A galvanometer would look like this. But normally when we see this, when we see this, it's an indicator that it is producing what? AC. Okay? It's an indication that it is producing what? AC current. Okay. So instead of a galvanometer, what can we call it? But it indicates that AC current or alternating current is produced. Alternating what? I'll remember the name just before we finish. Polarity of the magnet, guys, it's a generator. It's a what? Generator. What are we using? GR. God rules my life. It's a generator, so it's right. Right hand. We're looking for, we already have the direction of the current, right? Where's the current going? Current is the second finger. Yeah. The second finger. And this thing is moving, and it's moving what? Clockwise. Okay, so the best thing is to use like a page. Those of you at home now, I'm sure you won't be able to see me. I'm very sure of that. But if you get a page, this thing needs to flip towards the right-hand side. All right, so the best thing is put your thumb on the left-hand side at the bottom. All right, guys, if you can get a page, it's too late to get cameras now. If you can get a page, all right, this thing must flip towards the right-hand side. If it's flipping towards the right-hand side, place your thumb right here, pushing this thing up. Done. Now, the second finger should be where? Coming out this way. That's current. And if you do that, you would see that you are actually pointing from here to here. So Y becomes what? The north. Y becomes the north, and that becomes what? The south. Quickly, 10.3. A maximum voltage of 311 is used to dissipate an electrical energy of that joules through 50 ohms resistor appliance connected to an AC generator. Calculate the time to produce what? What do we have? I always like to quickly write what I have. What do we have? We have Vmax, because I said maximum, right? 311 volt. What else? Oh, hold on. Why jumping? Electrical, electrical what? Energy, which is work, right? Energy. Yeah, 9672,1. What else do we have? Resistance, 50 ohms. What are we looking for? Time. Is there a formula that connects all of this?
Yes.
What's the formula?
E is equal to V squared delta T over R.
Oh, you're talking nonsense now. Okay, let me give you a formula page quickly.
W is equal to, it is. Somewhere, wait.
Which one are we using? Which one? What?
It is the bottom left.
W equals to V squared delta T over what? R. Okay, and that is your W. So W is equal to what? V squared delta T over what? R. But the challenge is I cannot use maximum voltage. Every time we calculate power, it's VRMS. So VRMS is what? Vmax over root 2, which is what? 311. Guys, I can't be doing this maths for you. You are all maths learners. You are all maths learners. Let's substitute. 9672,1. What is V? 311 over what? Root 2. Check. Squared times what? Delta T over what's my resistance? 50. Somebody please do the maths for me. Let's get the maths. Ten seconds. Somebody confirm it? You're saying no.
10 seconds.
1 times 10 to the power 1.
10 seconds. 10 seconds. Okay. All right. That thing there, it's an AC source. So that's where we are going to connect our external what? Circuit. So it's an AC source. It indicates that alternating current is what? Produced. It's fine. It indicates or produces, or we can say produces what? Alternating current. No, alternating current is actually wrong. Produces what? Because if I say alternating current, what am I saying? Alternating current. Because AC already is alternating what? Current. So please take note of that. It's an AC source. All right. The last one. Let's run through our last question. We made it. We're doing all the four that we said we would. Oh, yummy. Photoelectric effect. Huh? Okay, quickly. 10 minutes. 10 minutes. Added 1 more minute. Okay, guys, I'm sure we are all done and just waiting for answers. Let's see. The diagram below represents electrons from transition A to D, and you can see they are moving down. And if they move down, they lose what? Energy. That tells me that for them to lose, they are emitting. So already I know it's an emission spectrum. All right, the light produced during each transmission is incident on metal Q with a work function. Please, that's the first information that I have. I have work what? Function. Transition C produces light of frequency. Take note of those. Define the term work function. Work is energy. So what is that? Minimum what? Minimum energy required to do what? Eject an electron from the surface of a metal. So every time you see work, quickly know that it is what? Energy. Number 2, what type of spectrum? We spoke about it. What is this? Emission. Why are we saying emission? Energy is lost. Energy is lost in terms of photons. We lose energy in terms of photons. Number 3, calculate the speed. We're looking for V of the photoelectron when the light from transition A is incident. Okay, look at transition A. The first thing I'm going to get, what can I get from here? Is the energy. So what is the energy of A? We can subtract. Negative what? 7 times 10 to the power negative 19 minus negative 3 times 10 to the power negative what? 19. Negative is what? Positive. What would that give us? So we know that, please check, the negative is only telling you energy is lost. All right? But the energy of the photon itself, the energy of the photon, remember I told you, energy is lost in terms of photon. So we are losing 4 times 10, but the energy of the photon is 4 times 10 to the power what? 19 joules. It's a scalar quantity. What are we looking for? We're looking for V. What formula should I use? E equals to what? Work function plus kinetic what? Energy. So E is work function plus, because I'm looking for V, I'm going to break that down. What is my VE now? 4 times 10 to the power what? 19. What is our work function, by the way? 1 times 10 to the power what? Negative 19. What is M? Mass of an electron. 9,11 times 10 to the power negative 31. And we have what? V squared. I hope we can all do... Oh, there's a negative 19 here, right? We can... Yeah. All the exponents are negative 19. Okay, this is simple. If we move...
8, 1, 1, 5, 5,
2. 8?
1, 1, 5, 5.
Final answer.
Yeah.
8?
1, 1, 5, 5, 2.
Oh, Lord. Can you give me in standard form? Shift mode 7, 3. 8, comma?
1 times 10.
You said 115.
Yeah.
So it's 8, comma 1, 2. Times 10 to the power?
1, 2, 3.
Oh.
Yeah, that's it.
You have to... Okay, guys, I don't know if you know the steps of doing this calculation. Let me just guide you on a calculator quickly. So I'm going to quickly bring that 1 over, right? That gives me what? 4 times 10 to the power negative 19 minus 1 times 10 to the power negative what? 19. That's that. We can just divide all of this by that entire block there. 1 over 2 times what? 9,11 times 10 to the power negative what? 31. But that is V squared. So square root of my answer. Why am I having that? Okay, I think I know why. 3 times 10 to the power negative what? 19, right? I think I know why. Divided by, yep, this is why. 9,11 times 10 to the power negative what? 31. I didn't put a bracket, it's important. Now we find the square root of that answer. Do you see the importance now of that bracket? Very, very important. Guys, are we okay? Are we good? Okay, let's finish up now. I'm just taking 1-2 minutes of your time. Value of x. What is the value of x? How did you get that?
753.
Oh, no, they told us transition C.
Oh,
Transition C produces a frequency. So we know the frequency of C. Let's see, will that help us? I think that should help us, right? Yep. Transition C. We know the frequency. What are we looking for? We're looking for X. Okay, hold on. If transition, be careful of that answer as well. Transition C. So the energy of the photon of C is F times what? Wavelength. But we don't even know that, right? So can we use, what am I writing that? It's HF, right? Good. What is H? 6,63 times 10 to the power negative what? 34. What is the frequency? 0166. What's this giving you? This is not the final answer though. This is not the final answer. Huh? 2 times 10. The amount of energy lost. So the energy lost is what? Negative 2 times 10 to the power. So we're starting from 3. We lose what? 2. Does that make sense? That's the energy of the photon that is transferred. So what would this one be?
so if I read it off the diagram,
You can.
oh, okay, sure. And I told it to my reflective.
You call it an arithmetic sequence. But I don't know if they'll give you full marks.
Nah, that is silly then.
Yeah, because what's your justification that is 1?
Look, they're saying they go 1.4, 1.3, 1.2, 1.1. That's an arithmetic sequence on its own.
Wow.
Then look on the right, it's an arithmetic sequence.
Wow.
Simultaneous equation. V2 minus 2.
Oh, beautiful. Beautiful. These guys are too clever. Okay, quickly, let's answer this last one. How does each of the following affect the maximum kinetic energy? So we're looking for the speed. Now, quickly, this is what I wanted to listen to think about. They said maximum kinetic what? Energy. So we're talking about energy of the what? Electron. The only thing that affects this will be what? Energy of the photon. And what is the energy of the photon? E equals to what? HF, or E equals to what? HC over. Okay. Intensity remains the same. That has nothing. Because what must affect must be what? Energy. What about wavelength of the incident light decreases? Look at how I analyzed my formula. So the things that will affect energy would be frequency and wavelength. But if wavelength, what's the relationship between energy and wavelength? All right. So if the wavelength decreases, what happens? The energy will what? Increase. So give a reason for your guys. We have already explained. They are inversely what? Proportional. Are we okay? Okay, we're going to finish this by multiple choice. They will fulfill everything we needed to do. Everything we needed to do was well done. Time well managed. Our next session will run from Doppler effect back up now. I want to make sure that every aspect is touched. Please keep practicing. Okay, quickly. This one is 30 seconds. Come. In an investigation, please get this right. In an investigation on the photoelectric effect, the graph of maximum kinetic energy versus frequency of incident light is drawn. The y-intercept and the gradient. Come, quickly. A, B, C, D. Quickly, I need A, B, C, D. And my accounting learners can go back to their accounting. Okay, can I quickly show you what to do here? Look at this, right? Frequency. What is your formula of E? E equals to what? HF. That's your constant. So Planck's constant is either D or, but we know this as our what? Work function. So the correct answer is B. Guys, are we okay with everything we've done today? Very, very productive. I love it. I love every question, every interpretation. Are we okay, everybody? Is there any question? You know the secret here is y equals to mx plus what? C. And what would this x-intercept would have been what? If they ask for this, what would this be? Threshold what? Frequency. Okay. What if, look, traditionally, we're just looking at basic traditional graphs that you don't need to do all those formulas for. You must just know these ones. If this is EK and this is 1 over wavelength, this one will still remain what? Work function. Look at, give me the formula of E that has wavelength. All right, then we're done. Gradient is equal to what? HC. Good night, everybody. Accounting students, please, good luck. Those of you not doing accounting, don't sleep. Fire on for your next subject. Please don't go and say, oh, I'm not writing accounting tomorrow. Let me scroll on my TikTok. No. Goodbye, everybody. Lovely lesson. Please watch it again and let's put down questions that we may have.